Hello. In this tutorial I make a little conclusion and to remember those subdivision themes in my Tripscode program. And I was talking in previous videos how this subdivision is organized here. And I show a little bit this drawing here about subdivision. And we see here in this drawing our purpose is to achieve this row for this edge. And we see this inside edges that emanate from the central vertex. And this central vertex is sort of, we call it polyvertex. And what about, I wish to show special vertex here on the edge of this polygon in the center. This is a edge vertex here. And how to create the first step or first goal is to create a row of those points here, that go through this band. And how to create it when we have the organization. To create this row and this sort of tasks, to accomplish those tasks, then we need a clear understanding how those points are organized in the program. And how they are organized and what I found out inspecting the code. Let's take a look at the code first here. And we see here in the code, we inspect this object subdivision function, and we are first thing to inspect is this part of the code when we start the edge counting. And this is the previous section. And what does it mean? This means that when we subdivide, then I go into drawing again. And this edge counting means that we are starting to count those unsubdivided edges, those for polygons. And for every edge, we got here 5 edges, for instance. We get 2 edges, those smaller segments. And what about those edges is important to understand that this central vertex here connects to the cage indices, and we see this in the code here that this IDX is used as a central vertex for both edges, E0 and E1. And those E0 and E1 become the sub-edges for this edge. So to say, they belong to this long edge, those 2 segments, and they are the subdivisions of this long edge. And they are connected with this new vertex. And this new vertex here is with index IDX. And this index comes from vertex count plus edge count, the current edge. Meaning this vertex count means all the previous vertices of the previous subdivision level, they stay in front of the array, and then those new vertices are added for the edges, for every edge. And these new vertices then connect those smaller segments in a fashion that first counterclockwise. We see counterclockwise. We have this point first, then we get this central vertice for the first segment, and then we get this next segment starting with central vertice and ending with the gauge index. And those gauge indices correspond to the previous subdivision level. That's why they match up. That's the first thing to note, how those segments for those edges are addressed. But then when we got those edge vertices in place, added to the gauge vertices, then the final step is to add this central vertice and add those new edges inside edges. They are another type of edges. This edge is the same level. I draw here a quadrant here, and those edges, 4 edges that I expressed here, that they are belong to the same level. Meaning when we get unsubdivided geometry, then the subdivision level is -1. This one is already at level 0, and this smaller quadrant is at level 1 subdivision. And let's go to the next part. We're got understanding how those central edge vertices relate and are organized in the arrays. But what about this vertice here, and what this is? And we go to the next section here, and we see that we get I explained it in a previous video or tutorial about it, but here we go again for this section of code. Yeah, and we see we get this poly counting running, meaning when we got geometry, then we got various polygons connected, and there are many of them. And we count those polus to add those central vertices, and then for every poly edge, this inside edge, and we then connect all this geometry together. And the interesting part here is this quadrants vertices organizations, and I found out that this central vertice acts as a 0th vertice for those quadrants, for all of them, and they run a counterclockwise fashion here, starting here, then they navigate backwards in the edge vertice, perimeter edge, and connect here, then they connect to the gauge vertice here, and then it loops back to the 0th vertice, and for every instance of those quadrants here, the same thing happens. This is one thing to note for this 0th vertice of the quadrant. This equals to vertice count, and those vertices then are counted, meaning they start from gauge vertices plus the edge vertices, and then those central vertices are announced with a vertice counter here. And we see here this quadrant first vertice at indice 0 is also equals to this counter. And the next line makes sure that it is the previous polu edge indices. They are all indices here that are numbers are assigned here. And this way it loops in a counterclockwise fashion back. And now what about this central vertice? Then we go already into next subdivision level, and the function to observe is of course then subdivide quads, but we don't need to go there because it's in a similar fashion. The principle is the same. And here we see we are also those inside edges, and maybe we don't know exactly where those edges start for every polygon or quadrant instance here. We know that they run into counterclockwise fashion, but at where they start, maybe they start here at this first stage. This was the because it means the first vertices here, but those edges don't correspond to those vertices necessarily, so they can start at any of those directions right now. And probably we need to run a little test here to find out if this edge's second vertex or the last vertex meets this edge vertex here, and when they match up, then this edge is then found. And then we go over the loop and find opposite. We skip the one edge and then commit with the first edge. First, second, third and fourth. And this maybe is a conclusion right now, but afterwards if we wish to push those patches further, then we of course remember this line segments, and then we use this so those say subdivision line here or band to find its sub-edges and corresponding subdivision polygons that are connected to this band. And then we need more complicated and intense systems to come up with further subdivisions here. Of course, when we create a patch structure for every polygon, then it makes our structures and data sets maybe very large, and maybe it is better to limit yourself with a few subdivision levels and use faster navigation here to avoid large data. But maybe it is not a problem. Maybe we should still come up with data sets for patches for every polygon and polygon's edges, meaning those bands belong to the edges, and then they cross, and then those values are interpolated for the curve segments here on the extremes.